Here we go. So you have part 4 of the summary and application. We've learned 4 variables of transformation: A, B, H, and K. Agreed? All right, of these 4 variables, each one affects X or Y. So A, which one does it affect? X or Y? A affects your Y. Part 1, A affects your Y. That's our vertical stretch or, there we go, our vertical stretch or compression. What does B affect? X. That's going to be our horizontal stretch or compression. What does H affect? X. That's going to be our left or right translation. And what does K affect? Y. That's going to be our up and down, right? So that's the conclusion of what we've been doing. Agree? Anyone's like, Miss, you were making no sense. Okay. Putting it all together, we are, so the teacher, yeah, I said it's going to make sense because it's going to be all together for you. The teacher that made this, they used D and C instead of H and K, but we're going to use what is in pre-AP algebra, okay? So K is our D. If I have a K value, aka a D here, that's going to be my vertical translation. It's going to cause the function to go up and down. Do we see that? What that means to my ordered pair is that to my Y values, I'm either adding or subtracting. Still with me? All right. Now, for H, remember with our H, it affects our X's. And we got to remember X's are what? Liars. X's lie, okay? So if it says X plus C, I'm actually going to the subtract. And that's going to make me move to the left. If it says X minus C, I'm actually going to the right, which means I need to add, okay? So remember that. This is what part 1 was all about. Going up and down, left and right. Are we good? Okay, part 3 that we're going to breeze through and kind of skip over is about reflections. So it's saying if your number is negative, so if you have a negative number on the outside, it's going to reflect over the x-axis. And that means that you're going to be multiplying all of your y's by a negative. And that makes sense because if I have something up top and I reflect it, what happens? It moves to the bottom. It's going over the x-axis, right? Yes? All right. Here, it says f of negative x. That means I'm affecting the x. And it's going to cause it to reflect over the y-axis, which again makes sense because if I have something over here and I reflect it, I'm changing its x values, it's going to reflect over the y-axis, which means that I'm multiplying all of my x's by a negative. So if it's positive, it becomes negative. If it's negative, it becomes positive. That's all I'm doing with the reflection, okay? That is what part 3 is about. So this is what part 3 of our notes is about, okay? Part 2 was our vertical stretch and compression. If it's an A, it's on the outside, correct? And that's going to either be a stretch or a compression. Think about the taffy. If I pull my taffy out, it's going to get skinny, right? It's going to stretch out. So I'm pulling a lot. I'm going to stretch. If I compress my taffy, it's going to flatten and get wider, right? Yes? Agree? All right. And that's affecting our A. If I'm going vertical, I'm going to multiply all of my y's by A. Got it? All right, B. B is on the inside with X. And what do we need about our X's? Our X's lie. Okay? So even though B is greater, it's a compression. Think about playing the accordion. If I apply more pressure to the accordion, what is it going to do? Shrink in, right? It's going to compress. It's going to shrink in if I apply more pressure. So the more pressure I apply, it's going to be a horizontal compression, right? Now, the less pressure I apply to the accordion, what happens to it? It stretches out. That's why it's a horizontal stretch, okay? So if B is greater than 1, I'm compressing. If B is between 0 and 1, I'm stretching out. I'm a stretch. Got it? All right. And our X's are liars. So it looks like multiplication, but it's actually what? Division. You're dividing by the B, okay? If you don't remember dividing by a B, that means you're multiplying by the reciprocal. Dividing by B and multiplying by the reciprocal are the same thing. Okay? Meaning if I divide by 2, that's the same thing as multiplying by 1/2. Does that make sense? All right. How do we feel about the summary of all parts? Does seeing it all in one kind of help know what's happening? Yeah. Okay. You need what? I couldn't hear what you said. Oh, okay. All right. So our function transformation forms. We have been working with 3 functions mainly, and those 3 functions we're going to identify them. So first one is our linear function. If we have a linear function, that means that normally f of x equals x, right? It's just a line, correct? In transformation form, a linear function. So if I was to transform this, by show of hands, how many of you remember point slope form? Point slope from Algebra 1, beginning of Algebra 2, y minus y1 equals m times x minus x1. Rings a little bit of a bell. That is the transformation form for a linear. Except if we're writing with a, b, h, and k, it looks like this. A parentheses x minus h plus k. Where a is your slope. And once you multiply and combine h and k, that's going to be your y-intercept. Okay? All right, quadratic. The quadratic parent function looks like f of x equals x squared. Agreed? Quadratic? Sir. F of x equals x squared. So when I write it in transformation form, it would be f of x equals a parentheses b times x minus h squared plus k. Okay, notice here your b has to be factored out. This has to be a factor. And by factor, that means it has to be something that's being multiplied to the x and the h. Okay, our next function that we've worked with is our absolute value function, which is f of x equals absolute value of x. Agreed? We've all worked with this guy. Its transformation form would be f of x equals a absolute value of b times x minus h plus k. And again, your b has to be a factor. Okay, so that means we have to take it out. So if it's at 2x plus 5, we would have to divide by 2. So it'll be 2 parentheses x plus 5 halves. Okay, knowing the transformation forms are going to be useful, especially for our next example. Are we ready? All right, so flip it on over. Your handy dandy note. So example 5, it says find the function that is finally graphed after the following sequence of transformations are applied to the graph y equals x squared. So we are working with our quadratic. Why? Because what kind of function is this? It's x squared, so it's quadratic. So we're going to be using the rule of f of x equals a parentheses bx minus h squared plus k. Our job is to figure out what's a, b, h, and k. So these are the descriptions that it gave us. It says you're going to shift right 3 units. So if I'm going to shift right 3 units, which variable is that? A, B, H, or K? H. It's our H. Good job. So we know H equals 3. Okay? If I want to reflect about the x-axis, is that A, B, H, or K? H. It's A. It's going to be A, and our A is going to have to be a negative. In order to reflect, it has to become a negative. We want to shift down 2 units. It's going to be our K, and K is going to equal -2. Because it mentions nothing about a stretch or compress for B, do I have to worry about it? No. So we're just going to plug in what we know. So this function would be, what is A? -1. Do I need to write the 1, or can I just put a negative? I could just write the negative. So A is negative. I don't have to worry about the B. My x is going to be there. What is H? H is 3. And then what's our k? Minus 2. And there is our k. So our function is,
So B just disappears.
B just, it becomes Casper, the friendly one.
Okay.
Because it didn't change, B equals 1. And if you multiply anything times 1, it is its self.
Okay, makes sense.
So if I gave you transformation rules, could you create the function? Yes, because you just have to be able to tell me what's A, H, K, and B.
So basically it's like plug and chug.
It's plugging and chugging. Identify, plug. Identify, plug. Got it? Yes? All right. Last is a transformation graphing. When you're graphing, you want to identify whether it's linear, quadratic, or absolute. As we learn more functions, we'll worry about more functions. But the first thing you want to do is, what would your original f of x have to be? It would be what's x squared? Quadratic. So my original is a quadratic. So I'm going to first write down the quadratic. Now, for the quadratic, we want to use the smallest x values. We're not going to use giant x values. We're going to use the smallest x values. So we're going to do -3, -2, -1, 0, 1, 2, and 3. What is -3 squared? 9. A negative times a negative is a positive. -2 squared? -1 squared? 0 squared? And then 1, 4, and 9. Okay, so that's our original. Our rule says we want 1/2 x squared plus 1. Which variable is 1/2? A, B, H, or K? It's outside. It's not with the x. It's outside of the x. So it's our A. And plus 1 is going to be our what?
That's gonna be
Our K. Perfect. A and K affect x or y. Look at your chart on the other side. What does A and K affect? The y. So that means all of our y's are going to change. So h of x is telling us we're going to take our y values, divide them in half, and add 1. So to each one of these y values, we're going to divide them in half and add 1. Are we doing anything to x? No, there's nothing happening inside of x. There's no parentheses saying x is doing something, right? Nope. So here we go. 9 divided by 2 plus 1 is what? 5.5. 4 divided by 2 plus 1 is? 1 divided by 2 plus 1 is? 1.5. 0 divided by 2 plus 1 is? 1. And then what are the values are going to do on the other side? They repeat. So we're at 1.5, 3, and 5.5. Okay, so now we're going to use these x values and our new y values to find our function. So I'm going to go to -3, 5.5. So 1, 2, 3, 1, 2, 3, 4, 5. Are we good? -2, +3, 1, 2, 1, 2, 3. -1, 1.5, -1, 1.5. We're going to have 0, 1, and then I'm going to repeat it on the other side. What's wrong with it? I know. I think it's on ink save mode when I print. So. Okay, pretend that I went through that point and that point. No, I can't even pretend. Can't even pretend. I tried to lie to myself and it did not work. Let's try again. Keep hope alive.
the X and the Y.
Yep, you know. Improvement, exactly. All right, so we can describe what happened. We had a vertical what? We had a vertical shift, but a vertical what? What did the 1/2 do to our function? Compress. There we go. We had a vertical compression or shrink by 1/2. What else did we do? What did the +1 tell us we did to our parent function? And we did what? Shift. It was a shift up 1. Okay, because of this, our domain is still what? All real numbers. You were getting there. I felt it in your spirit. And our range now, where does our range start? What is our lowest y value? 1 and continues to infinity. Okay, so the goal is now to be able to do multiple transformations and to be able to write the transformations. Okay? Which one? All right.